All right, here we go with more of quadratics. Now, I told you this is standard form that is on your reference sheet, and when it's in y equals format, and you've got the x squared term, the x, and then the number on the end, this plain number on the end is your y-intercept. If this number that's in front of the x squared is positive, it makes a smiley face. If it's negative, it makes a frowny face, okay? So you can always just make a little sketch if you can see the equation, and then kind of go from there on stuff. This one, they give you a picture, and we want to find all these pieces to it. So when they ask for vertex, they want the ordered pair of the location of the vertex. Now, where is the vertex on the parabola? It's where it changes direction. It's going up, 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 and then down, down, down. So where it changes direction is that point right there, that tippy point. So I want the ordered pair that goes with that. So start at the origin, and you always do the x number first. I don't need to go right to get to the vertex. I'm going to go left. I'm going to go 1, 2, 3. So that's -3 to the left and up 2. So -3, comma 2 is the ordered pair that goes with that point right there. So the vertex is -3, comma 2. And put parentheses around it because it's an ordered pair. That's what tells people that's a location on a graph. All right, so there's the location of that point. When they ask you for the maximum value, they want to know the highest number that this thing goes up to. So max is y numbers. Y's go up and down. So what's the highest number it goes over to? If you want to come across to here, you can, but you can see it right here in the vertex. That y number in the vertex is your maximum number. It is a 2. And it is a maximum because it is the highest point up here. Axis of symmetry. That's that imaginary line that goes right down the middle. And it starts with x equals a number. You can see the x there in the word axis to help remind you it starts with x equals. All vertical lines, this vertical line that goes right down the middle, is going to start with x equals. Vux for vertical, x equals a number. What is the number it goes through? It goes through -3. So x equals -3 is the equation of this vertical line that goes right down the middle. And you can see that's -1, -2, -3 on the x-axis. That vertical line has that equation. All right, so when they ask you for axis of symmetry, they want the equation that makes that vertical line. The zeros, those are other names for x-intercepts. It's crossing right here on the x-axis, and it's crossing right there on the x-axis. Now, in general, if it's crossing between two whole numbers, you assume on a graph that it's halfway. So that means this is -1 and that's -2. So this point is -1.5. You always assume it's halfway. So -1.5 is one of my zeros. The other one is over here. So this is -1, -2, -3, -4. So it's between -4 and -5. So that means it's -4.5. It's halfway between -4 and -5. So those are my zeros. The y-intercept is where it's crossing the y-axis. If you come down here and look really closely, you can see that point right there. That one's a little bit to the left of it. This one's a little bit to the right. So it's right there where that point is. So count down. -1, -2, -3, -4, -5, -6, -7. So my y-intercept is at -7. That's where it's crossing the y-axis. So those are the attributes. If I give you a graph, you need to be able to pick those points out. You need to know where they are. The vertex is the whole ordered pair. The max or min number is the y number in the vertex because that's the highest point or the lowest point that it's going to. And max and min are always y numbers. What's the highest number? What's the lowest number? The axis of symmetry is the equation of that vertical line down the middle, and it will always be x equals the x number in the vertex. So x equals -3. The zeros are where it crosses the x-axis. And then, of course, the y-intercept is where it's crossing the y-axis. Okay, now these, notice, don't have pictures. However, we have a graphing calculator. So in these equations, I'll start with y equals so you can put it in the calculator and look at it. I'm going to show you how to do that. Now, remember I told you a while ago, you can, before you even put it in the calculator, do we know what the y-intercept is? Yes, this number on the end is -1. That's where it's crossing the y-axis. So I already know that y-intercept is -1. Now, is it going to make a smiley face or a frowny face? This number in front of the x squared is negative. That's frowny. So it has a maximum. And so this is asking for maximum, so that is correct. It is a maximum, not a minimum. Now, to get the vertex and the other things, the easiest way to do it is just to put it in the calculator. So here's my graphing calculator. It adjusts. There we go. I've already got this first one typed in. Okay, I went to my home key and I went to the graph icon, typed it in. I'm going to hit enter. So let me find my enter. There it is right there. And there's my graph. Now I want to trace around the parabola. So I need to go to menu 5.1. Menu, oops, there's the menu button. Menu, and then over here on my screen pops up the menu. And of course, if you look at the menu, I want to trace. So that's number 5. So hit number 5 or scroll down to number 5. And then I want to trace the graph because that's what I have as a graph. So menu 5.1, when I hit that, this cursor appears. So right now, this is the coordinates of that point right there. And right now, I am physically on the y-axis. So that is my y-intercept. Negative 1 is the y-intercept. It's 1 unit down from the x-axis. So negative 1 is my y-intercept. Did we already know that y-intercept was negative 1? We did, just from looking at the graph, or the equation. So either you look at the equation, or you can look at the graph and see that the y-intercept is that. Now we want to trace around and find the vertex. So I'm going to trace around to the right. So I'm going to use the right arrow key and just press the right arrow key until it goes up. Oh, we just passed a 0. Let me go back to the left. We just went through. Right there is an x-intercept. And look at this number. Now, this is your x number. 0.184 is the x number. Sometimes they're not pretty numbers. This negative 1.3 to the e to the negative 12, that means there are 12 decimals to the left of this. So I move this decimal 12 places to the left. That's like 0.00000000013. So that is in essence a 0. This is sort of like rounding to 0. I don't know why some of the calculators have this in scientific notation to give the numbers this way instead of just giving you a 0 here. But when you get this E number, that's a big negative number, that means this is a really teeny tiny number, which is in essence 0. So this is like having a number here and then a 0. So it is, and it tells you up here you're on the 0, you're on the x-axis. So this is my x number, 0.184. So in this blank here under my zeros, I'm going to put 0.184. That was a positive number. So now I'm going to continue scrolling around with my arrows to the right. So I'm going up, 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 and there is my, it tells you we're on the maximum right there. So this is the vertex, 1, 2. I'm over 1 and up 2. So my vertex is 1, 2. Now that I know the vertex, do I know the maximum number? Yes, it's the 2. The graph never goes above 2. The axis of symmetry is always x equals a number, and what is the number? It is 1. If you look over here, that line that goes right down the middle of this goes right through 1. There's the 1 on the x, so I'm over 1 and up 2. The graph never goes above 2, so that is my maximum number there. Now, we need to go get the other x-intercepts. I'm going to continue scrolling to the right. And right there, it tells me I'm on the 0. It'll say the word 0 there. So here's my thing that's rounded to 0, and this is my x number, 1.82. So this is my second 0, is 1.82. So on each of these, you're going to do the same thing. You're going to put the equation in the calculator. You're going to go put it in trace mode, menu 5.1. Look at the words when you're doing it so you can do it without having to memorize menu 5.1. And then go find the vertex. Just trace around it till it tells you you're on the vertex. Tell me what the maximum value is, which is the y number in the vertex. Tell me the axis of symmetry, which is x equals a number, and it's the x number in the vertex. Trace around, find the zeros where it crosses the x-axis. Trace around till you're crossing the y-axis, and put that number in there. Okay, so that's what you're going to do on number 7. So, if we want to go do that one real quickly, y'all go do it. I'm going to pause the video, go put it in your calculator, make sure you're using that TI Inspire calculator because that's what you're using on STAAR Test Day. So, go put it in the calculator. Go back to home, go hit the graph icon, and now you've got a blank to put this equation in. This already says that f of x equals is your y equals. So, you're just typing in the right-hand side of the equation. So, go do that one, pause the video. Okay, hopefully you did that. You came back, and this is what you got. You said the vertex was 1, 2. The maximum number, it was a frowny face because it was a negative number here in front of the x squared. So that was a high point on the graph, and that 2 was the highest point in my graph. The axis of symmetry is x equals the x number 1. That goes right down the middle of the parabola. The zeros were at negative 0.414 and at positive 2.41. And of course the y-intercept is this positive 1 on the end. Whether you graphed it or looked at the equation to find that, either way worked just fine. So pause the video and go do number 8 and 9. Same thing, put the equation in the calculator and go trace around it and find those attributes. Okay, hopefully you've done that. You've come back to the video. Here's number 8. Hopefully you said the vertex was at 2, 1. Now notice this one is a positive number in front of the x squared. It made a smiley face. So does it have a maximum value? No, it does not. This is a low spot. It has a minimum value. So you should cross this word off and put minimum there. And that minimum number was 1. It never went below 1 on the y-axis. The axis of symmetry is x equals, it's a vertical line, and 2 is the number that it goes through, x equals 2. Now this particular one, when you looked at the graph, the x-axis was down here, so did this ever cross the x-axis? No. So the solutions were none, and it crossed the y-axis at positive 5. And you can see the positive 5 up there in the equation, right? Pause the video, go do number 9 if you haven't done it already. Okay, number 9, again a smiley face because this number is a positive, so it made a smiley face, so it does have a minimum, not a maximum. So cross off the word max and put min there. It's a low spot. The vertex when you traced around was 1, 5. The minimum value was the 5 in there. It never goes below 5. The axis of symmetry is x equals that x number 1. The solutions, again, did not cross the x-axis, did it? So there are none. And the y-intercept, if you graphed it and traced around it, was 9, or if you just looked at the equation, it was 9. So either way you found that one was perfectly fine. All right, moving on to the next section. These are some questions that you might see on the STAR test. It says, where is the vertex located in the graph below? Well, of course, the vertex is this little point here where it's changing direction. So we want the ordered pair that goes with that. I'm going to go over, if you count these, 1, 2, 3, 4. You do the x number first, and then -1. So 4, -1 is the ordered pair that goes with that point right there. And 4, -1 is C. There we go. Now this one says the graph of the function, and there's the equation of this graph, is shown below. The question is down here. What are the y-intercepts and the x-intercepts of the function? So since they said y-intercept first, this first thing is going to be the y-intercept, and then the x-intercepts are going to be the next two. So we just need to pick out which one has what. So let's go find the y-intercept first. So follow the y-axis. This is where the y-intercept is, right there. So if I go down, it's -1, -2, looks like it's -3. So the ordered pairs, and they put these in ordered pairs, not just single numbers. So this point here, I run 0 because the x number is first, and you jump down to a -3. So my y-intercept is 0, -3. So let's go find anything over here that doesn't say 0, -3, and this one does not, so get rid of that one. Now the x-intercepts. You have one right here at +1, and you have one over here at -3. So again, they did these as ordered pairs, so this is x number first, 1, 0. And this one we went -3 and don't jump, so -3, 0. So I'm looking for those 2 points. I need a 1, 0 and a -3, 0. That one doesn't have -3. That one has -1. Here's my 1, but it's got positive. Here's my 1, and there's the negative. So it is D is the right one. So even though you can have the right answers, you have to be very careful that you pick out the right answer. Okay, let's go look at what else is on here. What are the zeros of this function? So zeros, if you know from your vocab, are the x-intercepts. Is this equation in y = format? Why, yes, it is. Can I just type this whole equation in the calculator and just go look at the graph and trace around it until I'm right on top of the x-intercepts? Yes. So go do that if you have not already done it. Put the video on pause. Go type the equation in on the graph icon. Put it in trace mode, menu 5-1, and go find your zeros or x-intercepts. Trace around it until it says the word 0 on the screen. Okay, hopefully you've done that one, and now you're back with me. And these were at 3 and -5 were the 2 zeros, so the 2 x-intercepts. So that was this first answer right there. All right, number 13. What is the maximum or minimum value of this function? Well, here is this lovely equation. Now, let's make a sketch of this. Is this a positive number or a negative number in front of the x squared? It is negative, and negative is sad, so that's the frowny face. So is this a maximum or a minimum? It is a max. It's got a high point. So it's not C and it's not B. So it's either a maximum of 7 or it's going to be not here as an answer. So I need to go put this in the calculator and go look to see exactly what the highest point is in that vertex, which is the y number in the vertex. So go put it in the calculator and go trace around it, menu 5-1, until you find the vertex and see if the y number is a 7. So go do that. Hopefully you pause the video and now you come back. And by golly, this over here, I forgot what the x number was, but the y number in the vertex was a 7. So the high point in the graph was 7, so A was the correct answer. Number 14, solve. And it's what actually just says which is one factor of this thing. So we just want to factor this. I don't have both factors to multiply together to see if it gives me this, so I do need to factor it by hand. So there is no GCF because there's no number that goes into 2 and 7 evenly and 15, so there's no GCF. So I don't like doing it with the number in front of the n squared, so I'm going to move it over here, slide and divide, which means at the n I have to divide by 15. So I make myself a little note of that. Rewrite it, n squared plus 7n, and then 15 times 2 is -30. So when I go factor this into a binomial times a binomial, I need to make a list of factors that will give me 30. So these two numbers multiplied together are going to equal 30. So I have 1 times 30, I got 2 times 15, I got 3 times 10, 4 won't go evenly, 5 times 6, 7, and 6 has already been used, so I'm done at that point. Now I need one that will add or subtract to 7. That's 31 and 29. Add them 17, subtract them 13. 13 and 7, 13 and 7 will work, and this is 11 and 1, so that doesn't work. So this, I need a positive 7, so I'm thinking the good guys need to win, and the bad guys should be the smaller number. So if I add these together, I get a positive 7. If I multiply these two numbers together, I do get -30, so plus 3 and minus 3 and plus 10 do work. So -3 plus 10. But I'm not done because I have to divide by 15. So if you put these fractions in the calculator, that n squared calculator, and let them reduce them down, this becomes n minus 3 will go evenly into both of those, so that's 1/5. And this one becomes 5 go into both of those evenly, so this becomes plus 2/3. We never leave them as fractions. The 5 goes in front of the n, so this is 5n minus 1 is one factor. Remember, factors are things that multiply together to give you that answer. And this, the 3 goes in front of the n, so this is 3n plus 2. So those are my two factors. And this, I don't see any 5s in these, but I do see 3n plus 2, and there's 3n plus 2, so a is one of the factors of that lovely trinomial. All right, let's see what the next page has for us. It's more of this lovely quadratic stuff. So here they've given us pictures, so we don't have to put them in the calculator. But this time they want us to find the domain and range. So remember, domain are all the x numbers in the graph, and range are all the y numbers in the graph. In the alphabet, x comes before y, and in the alphabet, d comes before r. So you can kind of pair them up that way. So domain, x numbers. If you focus on these x numbers, if I come in from the side, I touch the edge of the graph, but does it actually stop here at 1? No, it has an arrow. It's going to go right, slightly right, forever and ever and ever and ever. So eventually I will use all these x numbers to the right. If I come in from the left-hand side, it does not stop here at -5. It's got an arrow on it. It's going to go left forever and ever and ever. So will I use all the x numbers that way? Yes. So I'm using x numbers in both directions. So that's literally the words all real numbers. Or you can abbreviate it with that double R. So all real numbers. You can write it out in words. Every single x number, you can use the infinity symbol with it. But I want to use all the x numbers. Now range. Do I use all the y numbers going up? No. But I do have arrows on the bottom, so will the y numbers keep going down forever? They will, but what's the point where they stop? Up here at the very tippy number, that number right there. If I zoom in a little bit, that's a positive 6. So all my y numbers start at 6 and go down forever and ever. So I want all the y numbers less than 6. Now remember, I eat the big number. So when I do this, I'm going to say my y's, and I've got a 6 here. I don't want to eat the y's because my y's are not bigger. My y's are smaller. And since it's solid up here at the top, they go right up and equal 6. So all my y's are less than or equal to 6. So all these y numbers are being used in this picture. Okay, so notice the domain was all real numbers, but my range starts at where the tippy point is, right? The max or the min, and goes one direction only. Vertex. Here's my vertex right there. I want to find the ordered pair that goes with that. So I go left 2 and up 6. So -2, 6 is the vertex. So that's what I'm going to write down here, -2, 6. Always x number first, y number second. So from the origin, I went left 2 and up 6 to get there. Y-intercept, go find the y-axis, come down till you find right there where it's crossing at 2. So 2 is my y-intercept. Is it a max or min? This is a high point, so it's a max. And then they want you to actually find it. And that high number is a y number. It's that y number in the vertex is a positive 6. We never go above 6 on the y-axis. What are the zeros? Now again, you're between two whole numbers, so estimate it to be halfway. So that's positive 0.5. And you could have said 1/2 if you wanted to. And this one's between -4 and -5. So -4.5. Always assume it's halfway if you don't have any other, if it's not a graph that you're tracing it. But if they give you a graph like this and you're eyeballing it, then assume it's halfway. But if they give you an equation and you can literally trace it, go trace it and be exact. The axis of symmetry is the vertical line that goes right down the middle, and they want the equation of that vertical line. All vertical lines start with what letter? X equals. And it's just like bucks, it's x equals a number. And what is the number that this thing goes through? It's that -2 right there. If you want to come down to the x-axis, you can see it's -2. But this is x equals -2. So just looking at the vertex, you know x equals -2, and you know the max or min is 6. Okay, last thing. Is a positive or negative number? So remember when we have the equation y equals ax squared plus bx plus c. If it's a smiley face, this number in front of the x squared is positive. If it's a frowny face, this number is a negative. Is this a smiley face or a frowny face? It's a frowny face. So is this number positive or negative in this one? It's negative to make a frowny face. So that's what we're doing, is picking out whether it was a negative number for the a or a positive number for the a. All right, so there we go on that one. Try this one on your own. So stop the video, go pause it, go look at the picture, and go find all these parts. Hopefully you paused it and you're back now, and we're going to check the video. So domain, remember these are your x numbers, range are the y numbers. So if I come in from the sides, I'm focused on these x numbers here. If I come in from the side, it doesn't stop right here at this 2.5. There's an arrow on the end of this, which means it goes right, even slightly right forever and ever, and it's going to go slightly left forever and ever. So am I going to use all the x numbers both directions? Yes. So that is all real numbers, or you can abbreviate it like that. You could use infinity symbols too. Range, those are the y numbers. Notice my graph never uses the y numbers up here, so this very tippy point here is the highest it goes to, but I do have arrows here, so it's going to go down forever and ever. So I want all the y numbers less than 5. So all of my y's are less than 5. And is it solid up there? Yes, so it's or equal to. So all my y's are less than or equal to 5. The pointed part is toward the y's if they're smaller. Is it a max or min? It's a high point, so that's a max. And what is the actual max? It is that number right there, the 5. Oops, I didn't do the vertex yet. So the vertex is this little tippy point right here where it changes direction. So to get there from the origin, I went right 1 and up 1, 2, 3, 4, 5. So 1, 5 is the vertex. And then it's easy to see that y number is your max. The axis of symmetry goes through that x numbers. This is x equals 1. Axis of symmetry always starts with x equals 1 because it's a vertical line. And vertical lines always start with x equals. Zeros. Let's see where we're crossing. I know it looks like it's closer to 2 than 3, but again, since we're just eyeballing this, I'm just going to estimate it that it's between 2 and 3, and I'm going to say 2.5. And the other one over here looks like it's between 0 and negative 1. I know it looks closer to 0 than it does negative 1, but I'm still just going to estimate it at 0.5. The A number, is this a smiley face or a frowny face? It's a frowny face. So does that mean the A is positive or negative? To make a frowny face, it's negative. So this is a negative number. All right? Go do 3 and 4, and then come back and check your answers. I'll wait here. Okay, hopefully you've done that, and you've actually done it yourself because it's important for you to try these on your own to make sure that you know what you're doing. All right, so when you did this one, the domain, again, was all real numbers because it goes right and left forever and ever with those arrows. The range, on the other hand, started here at negative 4 and went up forever and ever. So all my y's are bigger than or equal to negative 4. Because it never goes below negative 4 on the y-axis, but these points are all being used up, and there's arrows up here, so it's going to continue up forever. So going up is bigger on the y-axis. So all my y's are bigger than negative 4. The vertex is this point right here. So from the origin, you went right to 5 and down to negative 4. So 5, negative 4 is your vertex. That means this, and this is a low point, so this is a minimum. So we circled min, and that min is negative 4. It's the y number in the vertex. The axis of symmetry is the x number in your vertex. It runs right through positive 5. It's the equation of this vertical line that goes right down the middle. So this is x equals 5. The y-intercept, it's where it would cross it up here, but since we can't see it on the graph and there's no easy way to even estimate it, I'm just going to say can't see it on the graph because it's just not easy to see that. Zeros, they're crossing right here at positive 3 and positive 7. So 3 and 7 are my zeros, the x-intercepts. And is this a smiley face or a frowny face? It's a smiley face. So is the A positive or negative? It would be positive, because if that's a positive number in front of the x squared, then it will make a smiley face. On this one, when you did it, again, the domain is all real numbers. Are you getting to see that the domain is always going to be all real numbers on a parabola? Because you got arrows on both sides, and they go to the right and left forever and ever? Yeah. The range, on the other hand, is going to start at some number and either go up or down. It's going to start here at negative 6, and they all go up. I want all the y numbers bigger than negative 6. So there's how I can say I'm going to eat the bigger number. The y's are bigger, so I'm eating the y's are bigger than or equal to negative 6. The vertex is right here at that tippy point. So from the origin, you went left 2, always x number first, y number second, down to negative 6. So negative 2, negative 6. That means my min, because it's a low point, minimum is at negative 6, the y number in the vertex, and the axis of symmetry is literally this equation, x equals negative 2. And there's my axis of symmetry. That is the equation of that line that goes right down the middle. The zeros on the x-axis are crossing between negative 4 and negative 5, so negative 4.5, and this is between 0 and 1, so 0.5. So positive 0.5 and a negative 4.5. Is this a smiley face or a frowny face? It's a smiley face. That means I have a positive number in front of the x squared, so my A is a positive number. All right, there's that. I've got one final video for the review stuff.